Okay, it's time once again for another thrilling episode of Asteroid Commander. So, I've done a couple of major changes to the program. One of them quite visible, and the other one not so visible. So, I'll go over the more visible one first. Um, so, what I've got here is just the normal view of the asteroid, where the asteroid itself is being drawn on 88 layer 1 8-bit per pixel tiles. And the other thing, um, well, there's actually two different maps of 88 tiles each for the asteroid, and while one is being drawn, the other one is being shown. So that's 176 tiles, but I've got about 48 tiles on layer 1 that I use for things like the borders around each of these windows, um, these red to green indicators here are not the slider on top of them, but just the indicator is 4 layer 1 tiles. Um, the the up and down arrow in the message window and the slider as well. Those are all layer 1 tiles, and UTC is layer 1 tiles. Now this is all in 8-bit per pixel mode, and it's also in 8-bit per pixel mode when you're in zoom out. But zoom in, this is the thing that I have added. Now, in this view, you're about 300 meters above the surface of the asteroid, and each of these triangles has got an edge of about 70 meters. So normal view, you're about 2 kilometers above the surface. The asteroid's 2 kilometers across, so you're about 3 kilometers from the center. And zoom out view, you're 15 kilometers from the center, and so 5 times further. So about 14 kilometers from the surface at the center. And so zooming into about 300 meters above the surface gives you this view. Now, the iris here is 16 sprites, and there's actually 2 frames of animation here. There's a halfway image that lasts for about 1/15 of a second. It's using 8 sprites. This is 16 sprites in the fully closed position, but you can see just a flash of animation where it's halfway, and that's just 8 sprites. But when it's so these are sprite number 30 to 3F. Inside here, I've got 48 sprites right now. Sprite numbers 50 to 7F are set aside for the terrain image sprites here. I haven't used sprite numbers 40 to 4F, though. Those will go for what I'm calling greebles, after what Adam Savage calls them. And that's just little sprites that will go on the surface that will give it a little bit of texture. So for the man-made stuff, it'll be things like antennas and pipes and vents and satellite dishes and that sort of thing. And so, yeah, level area, there'll be nothing. But yeah, anything that's man-made will have some kind of greebles on top of it that will give it some kind of texture besides what you're seeing here. And now you can rotate all of these, and they're a little distorted because I'm doing this on a grid here, and like I say, this is all with sprites and layer 1 tiles. Now layer 1 right now is in 4-bit per pixel, so the up and down arrows, the sliders, all of the borders here, these are all now 4-bit per pixel tiles around here. And the tiles that I had used for the asteroid before, now I've got 176 tiles in 4-bit per pixel mode that I'm not using. And so what I've done is I've created 15 4-bit per pixel tiles that are each one solid color. Now let me just bring that up here on my spreadsheet. This is how I design all of my tiles, and all of my sprites is on the spreadsheet, because I can just put a code in here to have it turn a palette number into a style, and all of my palette is declared as styles in the spreadsheet, so I can get an immediate look at what every tile looks like. So these are the 4-bit per pixel tiles. These ones look exactly the same as their 8-bit per pixel equivalents, because every one of these tiles is only using one row of the palette. It's all of them have the same high nibble for every pixel on the tile. They're all using like all threes or all twos or whatever. And so it's really easy to convert them all into identical 4-bit per pixel tiles. I just use the one palette offset for all of those. So yeah, I've got all of those done, plus I got 32 available, which I'm probably using for symbols for resources. And then I've got all 15 of these, which are all just one single color each. So by adjusting the palette offset nibble and selecting the correct tile, I can get any one of 240 colors for background tiles. Now, if I bring this is what I used to develop these images. First thing I did was came up with what I wanted as my desired image, and I've got 8 of those for the various different kinds of maps. So the ones on the right here, these are for 40 degrees north and south, because those areas are twisted about 15 degrees relative to the rest of the map. Let me just see if I can find one here. There it is. It's twisted just a little bit. But by only using those 2 images and then just changing which color goes where, and let's bring this up again here, and by having these sprites here, I have 15 sprites. They're all 8x16 triangles, each one all one solid color. And here you can see the sprites I used for the iris. There's a couple wider ones there. Oh, I lost them. There we go. So I've got 15 of these sprites that are all one solid color, but they're all these 8x16 triangles. I have another 15 that are all one solid color, but they're 16x8, and another 15 that are all one solid color, but 16x16 right angle triangles. And then finally 15 more, all one solid color, 15x15, but these ones are darn near equilateral. And it's these ones here that I am using here. So there's 42 sprites in this image here, and just gray background tiles in this image. And in here there are 40 sprites, and anything that's between the triangles is a tile. So if we go back to this, let's just have a look at these ones here. So I have my desired image at the top here, and so here I have what the tile colors should be. So they all correspond to a triangle up here. And then here's the sprites that I need. So there's a bunch of 8x16 sprites, there's a bunch of 16x8 sprites, and there's also a bunch of 16x16 sprites here. And when you take these and have white be transparent and superimpose them over top of these, you get this image at the bottom. And then I just added all the numbers to it to indicate the rotation. And so these 4 images is all I need, plus the those sprites. Was all I need to do this, and just changing the locations of the colors within the map means that I can do 20 different rotations. Now, this is not perfect by any means, but it's probably as good as one could get on the Commander X16 with just using tiles and sprites without resorting to a bitmap, which would be quite a bit slower for, and really not worth it for what you get, which is just single solid colors. Now, I mentioned before that the iris was sprites 3.0 to 3F, and these were sprites 5.0 to 7F. So I still have sprites 4.0 to 4F for greebles, not just on the buildings, but also here I can have mountain ridges and cracks, and in areas like this, I can have craters using. I can even combine 3 or 4 sprites to have bigger craters and irregular shaped craters, and just have them rotate with the asteroid or with the area that you're working on as you rotate the image. So that's probably the next thing I'm going to be doing here. But the other thing that I did was I tore this program apart and put it back together. And I changed part of the custom IRQ. I added this little section of code down here. It looks at the number of flag triggers that are present in the list of. I have a list of flag triggers. I have a list of timer triggers. Those two types of triggers are for events that happen sometime in the future that you want to either some condition is met, then the event takes place. So for flag triggers, or for timer triggers rather, those just get decremented every time the clock updates, and when they reach 0, that's the condition being met, and so then the event gets pushed to the event queue. For flag triggers, those have to be handled a lot more often. So I have them handled within the custom IRQ, and if I go to IFLT, which checks the flag triggers, inspects the flag triggers rather, what this does is the trigger consists of 5 bytes. The first byte is a 0-page address. The second byte is an AND mask. And if the contents of the 0-page address and the AND mask are equal to the AND mask, then that first test has passed. Then the third byte is an OR mask. So if the contents of the 0-page byte or the OR mask is equal to the OR mask, both conditions are met and the trigger fires. And how it fires that trigger is just by setting the 0-page pointer to 0 and setting bit 2 of the 0-page address flag, which is 7C. And it does that for each flag trigger that fires. It just sets it to 0. And well, it doesn't matter how many times it sets this, it'll still be set. So that's what custom IRQ does. Now, if we go to main, there is this function call here, HFEV, handle flags and events. And the first thing it does is checks whether you're in initialization mode or whether the game is running. In initialization mode, it doesn't want to be checking any events or any flags or updating anything. It's just coming up with the initial image of the asteroid. So if bit 3 of flag is reset, that means you're in initialization mode, and so it just skips all of this. But here, if bit 2 of flag is set, and that happens in IFLT, then you know that a trigger has been fired, and you have to handle that. And what it does is goes through the list of flag triggers, finds which one points to address 0. It knows that one has been fired, so it takes the event, which is byte 4 and 5 of the flag trigger, and pushes it to the event queue. And then regardless of whether a trigger has been fired or not. It looks at the event queue and says if that is 0, then there are no events on the queue. But if it's not 0, it handles the events there. And then there's this subroutine call to null here. Null is just a single byte subroutine, and it only contains a return from subroutine. So this is just a placeholder for what will later be the ADSR envelope handler. And that's for music. So I'm going to be adding music to the game, and I had to tear it apart to do this, to get for music and for animations, for anything that happens in just a few fractions of a second, less than a second. Um, you can see down here ECMA, EDRA, and ESTA. These three functions here are what gets called to enable the three longest functions in the program. CMAP, draw, and star take the longest time of any functions. And if I just go F1 here, you can see it's setting and resetting a whole bunch of flag bits in each one, and each one of these is setting this value CBL to 0. This is computation block number. If I go to main, so in various conditions, if various conditions are met, each one of these subroutines will be called. So if a particular bit is set, in this case bit 5 of flag 4, then show will be set. Show will be called. If bit 4 of flag 4 is set, then star will be called. And each one of these 4, star, draw, show, and CMAP, takes quite a long time. The 4 of them together, if you move to a new area or rotate your view, all 4 of them get called, and it takes about 1.5 million cycles, which is about a fifth of a second. And that's way too long to wait to change an ADSR envelope, or even a frame of animation that takes place in 1/15th of a second, like opening and closing the iris. It's way too long to wait for something like that. So what I did was I divided each of those 4 subroutines up into parts, and using CBL number, computation block number, as a counter. So if it's equal to 0, then it's the very first time through the subroutine, so it does a whole bunch of initialization, and that's what happens here. It gets the work area values, or gets the work area, checks the work area flags, displays the compass and latitude and longitude, initializes the sky map, and does the close-up 3D view, and then it calls HFEV, handle flag and events. So if anything has been set by the custom IRQ, it checks to see if that has happened, and if so, handles those, and then it goes on, checks whether you're in zoom in view or zoom out view, and if so, just jumps to those, handles those, and then goes to the end of the subroutine, which clears the flag that indicates you need to do CMAP, and then enables draw. But the other 22 times through the subroutine, it does this loop where it casts 256 pixels, figures out where on the map those belong, and then after doing that, increments the computation block number and calls HFEV, handles flags and events. So each time through this subroutine, it goes through it actually 23 times. It's checked HFEV as it does CMAP. Similarly, if I go to draw, so this one here, has a bunch of flags. It could either do the zoom in view or does the full asteroid view or the zoom out view, which is actually exactly the same as the full asteroid view. And at the end of it, it draws the close up and stuff, but I really should have it handle flags and events at some point in here too. Hmm. Actually, I think I do it when it's in the draw zoom in view. I believe that's when it does the handle flags and events as well. But yeah, it's throughout this one here. If I get down to the draw loop, which decides, given a particular location on the map corresponding to that pixel that was calculated by CMap, whether it's day or night color, and then uh, draws that color on the hidden screen. And then at the end of doing that for 512 pixels, it increments the computation block number, calls handle flag and events, and then jumps back to draw. So I've got draw divided up into 11 parts. I've got CMAP divided up into 22 parts. I've got star divided up into 4 parts. And that way, HFEV is getting called somewhere between 100 and 300 times per second. So later on, when I add ADSR, the subroutine that's going to handle the ADSR envelopes of all the PSG channels, that'll be right here. It'll take the data that's going to be updated by the custom IRQ. It's going to be one more thing added to the custom IRQ to update the counter if it's in attack, decay, or release mode. And then HFEV will use that counter to determine whether it has transitioned from attack to decay or decay to sustain or from release to zero, and select the appropriate volume accordingly. If it's in sustain mode, of course, it won't do anything to the volume. And so at the so yeah, that's going to be the next thing after doing some texture to each of the zoom in views with a bunch of sprites that have a bunch of the sprites I've already got designed for the craters and stuff. I haven't done the other greebles yet, but that'll be the next thing. So until then, have a good time, be kind to each other, or else, bad stuff happens to us. And yeah, happy programming.